Today we are finally going to start getting into some geometry work. We're done with our algebra review. We'll still come back to do some, to recover some things you learned in algebra as we need them. But we're done with our big algebra review for right now. So let's go ahead and jump in to geometry. Now, to start with, we need to define some terms. And the problem with that is, in geometry, there are three main terms: points, lines, and planes, but they're considered undefined terms. Now, in algebra, you use these a little bit. You definitely use points and lines. You used coordinate plane, and that's a plane. It was flat, but there's more planes than just that one. But in geometry, these are not terms that have formal definitions. They have some characteristics, some descriptions that everyone agrees on, but they don't have actual definitions. So we're going to have to try to define them without defining them. All right. The first one is a point. And of course, you know a point. We draw a point as a dot. But a point is basically a location in space. And when we talk about space, we don't mean outer space. We just mean in a three-dimensional world, or for the majority of what we do, two-dimensional flat area. It's just a location. It doesn't have any width or any depth. So even though the dot I just drew does have some size to it, a point has no size, no length, no width, no depth. When we name a point, we always want to use a capital letter. So we'll call that one point A. Our next term is a line, and you did lots of work with lines in algebra. But a line is a straight path and it goes forever in two directions. So if we had a line right here, it would go forever this way and forever that way. And all lines are straight. It irks me when people say straight line, because if it's a line, it is straight. Otherwise, it's called a curve. And lines have length, but no width and no depth. And when we draw lines, that's what they look like. It's a piece of a line, just a straight mark, and then we have arrows on both ends to indicate that it goes forever in both directions. Now we have a couple ways that we can name lines. We can use any 2 points that are on the line. So if I wanted to call this C and this point D, this would be line CD. Now, we don't like to have to write the word line over and over again, so we have shorthand ways of doing this. So if we just wrote the letters CD and then drew a line on top of them, a line that goes over C and D, then that is the same thing as saying line CD. We could also put them backwards, so line DC. Now we could use any 2 points on the line to name it, but we only use 2 points. So even if I had point Q in there, I could call this line CD, line DC, line CQ, line QC, line QD, line DQ. All of those would be okay, but we would never call it line CQD. Never use 3 points to name a line. Another way that we can name a line is with a lowercase script, forgot my I, letter. Now, most of us don't know how to write in script, and so we could just use cursive instead of script. If you aren't comfortable with cursive, then that's fine. You can just write it write it normally. When you'll see when I type things, oftentimes it's just italicized when we're talking about these. So, and oftentimes we'll just put that cursive or script letter off to the side. So this would also be called line L. Now our third and final undefined term is a plane. A plane is a flat surface. As I said before, you dealt with the coordinate plane in algebra, which was just a flat surface that you did all your graphing and plotting points on. It goes forever in all directions, but it's flat. So it has length and it has width, but there's no depth. So it doesn't come off the page, but it goes forever forwards, backwards, and left and right. When we draw a plane, we draw a parallelogram. That's what we use for plane. And we use 3 points to name it. So I'll call this, we'll just use X, Y, and Z. Now these 3 points can't all be on the same line. We'll get to that more in a minute. So this would be plane X, Y, Z. We could also use a capital or uppercase script or cursive letter. So we could call this plane R. That would work also. Both a line and a plane have infinite points. Obviously a point doesn't have infinite points because it's just one. Alright, so those are our undefined terms. All right, moving on, collinear points are points that are on the same line. Co means together, linear means line, so together on a line. Coplanar points are on the same plane. To have collinear points, you need at least 3, because any 2 points are on the same line, even if that line's not drawn. And for coplanar points, you have to have at least 4 points to call them coplanar. All right, so let's look at this figure and let's try to identify some things. 2 other names for line PQ. Well, PQ is this line right here, and gotta wait for that to go away. See how it has this dotted part here? That means that this line isn't on the plane, it's going almost vertically through the plane. It's kind of hard to show that on a flat surface, but that's what those dotted lines mean. So line PQ, we can always just turn the points around and say them backwards. And I didn't even do that, I wrote it forwards. So we could call this line QP. We could also call this, because we've got that N over there, we could call it line N. When we use that single letter for a line, we want to make sure we write the word line in front of it. For plane R, this just means we need to use 3 points that aren't on the same line. So we couldn't use S, P, and T together because they're all on the same line. But we could do S, P, V, those 3 points in any order. We could do STV in any order, or we could do PTV in any order. So that could be PTV or PVT or TPV or TVP or VTP or VPT. So those 3 points in any order would be fine. For B, 3 points that are collinear, Now, they're only collinear if we can see the line drawn between them or through them. And so that would be S, P, and T, because we see that line that goes through all three of them. For points that are coplanar would just be V, S, P, and T, because they're all inside that quadrilateral. Q is not coplanar with those because the picture has it outside the outside that plane. So try these other two and then we'll move forward. All right, for ST, there's actually several other names for this. It could be line N, or excuse me, M. It could be TS. It could be SP. It could be PS. It could be PT, and it could be TP. All of those are the same line. All right, and for part B, we actually kind of talked about this. Point Q is not coplanar. Oh, nope, that's wrong. Misread the question. A point that is not coplanar with Q, S, and T. Now this is a plane that is not drawn, so these are kind of hard to see. But if this were two pieces of paper that intersected each other, you could see that point V would be off by itself. We won't have a lot of questions like that, and we won't see this three-dimensional stuff very often in class yet. So if you struggled with that one, don't stress it. All right, a few other terms. These terms have definitions that we need to go over. All right, a line segment. You could say segment or line segment, same thing. There are two endpoints, and then all the points in between. And just like a line and a plane, this has infinite points on it. It just happens to have a start and a stop point. And we would draw it literally with a line segment. Sometimes we'll have dots on the end for those points, sometimes we won't. So if I called this JK, so to name this, we would use the two endpoints. Let me actually write that out. Two endpoints are what name it. And they could be in either order. So this could be JK or KJ. But here's the thing, we have to have a line segment above it. So when we're naming a line, we put a line above it. When we're naming a segment, we put a segment above it. So this would be segment JK. Now a ray has one endpoint, and it goes forever in one direction. So if we want to draw a picture, we would have an endpoint. Again, there could be a dot, there might not be, but the other side has to have an arrow. That's very important. And we would name this, we'll call this RS. We need 2 points on the ray, the end point and one other one. End point and one other point. So this could be called RS. With rays, you always start with the end point. Always start with the end point. So this could be RS. We could not call this SR. It is not ray SR because ray SR would start at S and go towards R. And that's not what we have here. Both segments and rays are parts of a line. Okay? Technically a ray is half of a line. Opposite rays are two rays that form a line. So they go in opposite directions, so when we put the two of them together, they actually create a line. So here we'll do we'll just go with ABC on this one. So ray BA and ray BC are opposite rays. And notice that both of them start with the same letter because you have to start at their end point. Another thing about rays, if we had another point here, we could also call this ray RT. That's the same thing. Because it goes forever, it includes T and S. We'll deal more with that as we come to those. All right, so example 2A, another name for segment GH. Oop, didn't mean to do that. That is this segment right here. And with segments, you can always just turn the letters around. So it's HG. For B, name all the rays with endpoint J. Well, here's point J. So from there, how many different directions can we go? Well, we can do JE. And I don't remember if I mentioned this, but when you're naming a ray, you put a ray over it. So line, put a line over it. Segment, put a segment over it. Ray, put a ray over it. So we've got JE. We've got JG. We've got JF. And we've got JH. So all of those are rays that start at endpoint J, and that's why J is listed first every time. So try these next two. All right, we've got segment EF. Okay, that's that segment right there. And again, it's a segment, so we can just turn the letters around. So segment FE. And then our HJ, I'm going to erase. No, I'm not. I'm just going to use orange and black. Our HJ, that's ray HJ. And JH, the same ray. Okay, those two are not because they don't start at the same end point. They have to start at the same end point to be the same ray. Then our HJ and HG, the same ray. And both of those start at H and go towards J or G, either way. So those two are the same ray. And like I said, because those two start with the same endpoint and go in the same direction, but HJ and JH start at different end points. Right. Two or more figures intersect if they have points in common. If you think about the intersection of two streets, the intersection is that square or rectangle in the middle that is part of both roads. So intersections are the points they have in common. When two lines intersect, they form a point, or their intersection is a point. Whether we make the dot or not, two lines intersecting tell us there is a point there. When two planes intersect, they intersect at a line. Now, drawing intersecting planes can be kind of a hassle. I've had plenty of practice doing this, so I'm a good bit better at it than you are going to be right off the bat. And again, this is like if you had two pieces of paper that crossed each other, and my planes don't look like they are flat, but I promise they are. Also, in geometry, you can never trust the pictures unless you are told things about them. So this spot where they intersect, that's always going to be a line, and I'll call this line T, just because. So when two planes intersect, they intersect and create or show a line. Even if it's not named, it's still a line. So that's it for your introduction to some of our geometry terms. Over the next few days, we'll start to use these basics. We'll deal with line segments and angles and congruence before we start to dive deeper into this. So make sure you fill out your Google form and get ready for that practice work that we will do in class. Good luck.